In 12.8, we're doing more trig graphs. And now they're going to be translated. So they'll slide up, down, left, and or right. All right, so for number 1, the first thing they want is the amplitude. And the way we find that, it is still the absolute value of what we see in front of sine or cosine. All right, next they want the period. And that is still 360 divided by what we see in front of theta. So in this one, it'll be 360 divided by 3, which is 120 degrees. All right, so now I'm going to put that on the x-axis. Then I'm going to cut that into 4 pieces. And on the y-axis, I want 1/2 and -1/2. All right, so now in red, I'm going to graph some points that would be on the graph if the -90 degrees was not in parentheses. So again, pretending -90 degrees was not there. Remember that cosine likes to start on the top level of the building. And then when you're on the top level, the only place you can go next is to the middle level, then to the bottom, then to the middle, and then to the top. All right, now those red points are not on the graph. They would be on the graph if there was no -90 in parentheses. All right, so what that -90 does, it creates something called a phase shift. And a phase shift just means the graph moves either to the left or to the right. And it's kind of backwards. So if you see -90, negative means to the right, even though negative numbers are on the left of the x-axis. Negative means to the right. So our phase shift is 90 degrees to the right. All right, so all of these red points need to be shifted 90 degrees to the right. Now it's kind of difficult to shift all 5 of them, so I would just shift the first one. All right, so this one I'm going to shift 90 degrees to the right. And now I'm going to ignore all of the other red points. If we have a point that is on the top floor, it's pretty easy to build all the other points around it. So when you're on the top floor, you must go to the middle floor, and then the bottom, and then back to the middle, and then going the other way has to go to the middle. And now I've graphed. Now I have a whole period of points. The directions also asked about a vertical shift. So we're not going to have any of those until number 5. A vertical shift is a translation up or down. And that would happen if there was like a plus or a minus after the parentheses there. So I guess I'll say there's none for this one. All right, number 2 is in radians. First thing they ask for is the amplitude. Remember that sine and cosine are the only ones that have an amplitude. So for this one, we could say the amplitude is undefined. All right, next we want the period. All right, so we look right there. We take 180 divided by the number we see. So it would be 180 divided by 1. However, this one is in radians, So it would be pi divided by 1. All right, and then remember that I prefer to graph 2 periods when I do tangent and cotangent. So I'm going to call this 2 pi. Cut that in half. That's pi. And then cut it in quarters. Pi over 2 and 3 pi over 2. And then on the y-axis, even though we don't technically have an amplitude, I want to use the number that's in front of tangent, and then the opposite of that number too. All right, next let's talk about the phase shift. So negative means to the right. So because this one's positive, this one's going to the left. So this one's going pi over 4 to the left. And then the vertical shift doesn't have one for this one because we don't see anything over here after the parentheses. So vertical shift doesn't have one. All right, so remember, after we double the period for a tangent, the first and the third tick mark are going to be asymptotes. However, this graph gets translated. So let me divide the x-axis one more time. All right, so I'm going to divide all these one more time. I'll do that in green. All right, so this increment, I cut pi over 2 in half. So those are pi over 4 apart. And again, remember that the first and the third blue mark would be the asymptotes normally. So where pi over 2 and 3 pi over 2, where those are, those would normally be asymptotes if we didn't have a phase shift. So because of the phase shift, the asymptotes are going to move pi over 4 to the left of that. So instead of at pi over 2, slightly to the left of that, we have an asymptote. And then instead of at 3 pi over 2, pi over 4 to the left of that, we have our other asymptote. We know that exactly in the middle of the two asymptotes, that's where the tangent graph will be at 0. And then we know that it goes up from left to right. So at pi over 2, we'll be at -1. And at pi, we'll be at +1. All right, then we make our tangent graph look something like this. We could make almost another period on the right. So at 3 pi over 2, that's where we're going to be at -1. And in between, that's when we're at 0. And then at 2 pi, that's where we're at +1. Right, so it's almost like I can make 3/4 of this, and then I'll just stop there. And then I'll make like a quarter period on the left. So at 0, that's when our y will be +1. And I just have this small part of the tangent graph. For number 3, remember that the amplitude is the absolute value of what you see in front of sine or cosine. So the absolute value of -1/2 is +1/2. Let's go ahead and put 1/2 and -1/2 on the y-axis. Right, the period, this one is also in radians. So instead of 360 divided by that 3, it's going to be 2 pi divided by 3. All right, so I want that on my x-axis. And now cutting it the way I usually cut it is kind of tricky. So half of that is 2 pi over 6, or pi over 3. Half of that is pi over 6. Pi over 6 times 3 is 3 pi over 6, or pi over 2. All right, in the parentheses with theta, we see a minus pi over 3. Right, so minus means it's shifted to the right. So this one is going to be pi over 3 to the right. And again, we don't have a vertical shift yet because there's nothing being added or subtracted after the parentheses close. All right, so again, in red, I will put points that would be on our graph if we didn't have that phase shift. All right, so sine typically starts on the middle floor. And then sine likes to go upstairs first, but because of that negative, you have to pretend like it's opposite day. So it starts on the middle floor still, but it goes downstairs first. Then it goes back to the middle. And then it goes to the top level. And then it goes to the middle level. So again, those red points are not on the graph. We need to shift those red points pi over 3 to the right. So to shift pi over 3 to the right, that's 2 increments on our x-axis. So I find it's easier to shift either a bottom point or a top point, but not a middle point. Middle points are tough because you're not sure if you're heading up or down from the middle. But if you shift a bottom point, you know that you have to go up from there. All right, so I'm going to shift this one. And so if that's going pi over 3 to the right, that takes me over here. All right, so if we're on the bottom level for that one, then you have to go to the middle level next. And then as I go to the left, it has to go to the middle, and then the top, and then back to the middle. All right, so it kind of looks like a normal sine graph. So the negative and the shift to the right basically just made it look like a normal sine graph. Let's start number 4 with the amplitude. So again, only sine and cosine have an amplitude. It's the absolute value of the number you see in front of sine or cosine. All right, then we need our period. So it's 360 divided by what we see in front of theta. So for this one, it's 360 divided by 2. So this one has a period of 180 degrees. Let's put 1 and -1 on the y-axis. And let's put the 180 on the x-axis. Right now, cut that into 4. So cutting it in half makes 90. This is 45. And this is 135 degrees. All right, let's write down the phase shift. So there's a plus 60 in the parentheses. So this one is going 60 degrees to the left. And still no vertical shift. All right, so in red, I'll put some points that would be on the graph without the phase shift. So sine likes to start on the middle level. Then it goes upstairs, back to the middle, then downstairs, then back to the middle. All right, now shifting this 60 degrees to the left That's going to be a little challenging because the x-axis is counting by 45 degrees, and we want to move 60 degrees. All right, so for this one, 60 would be like a third of the way between 45 and 90. All right, so what I want to do is actually cut these increments into thirds from here. So if I put one here and one here, those are like 15 apart. And I'm going to do the same thing here. So these are 60 and 75. All right, so I cut every little section into thirds. Try to imagine that's to scale. All right, and I want to shift all of those red points 60 degrees to the left. All right, so kind of hard to do it with the one on the top level. I think the easiest one to shift to the left would be this one. So to shift that to the left, 135 minus 60 is 75. So that point would end up here. The top point would end up going from 45 degrees to like negative 15. So I'm going to go a little to the left of the axis. All right, so we have a top level and a bottom level point. We need a middle level. So the one that's at 90 degrees, comma 0, that's going to 30 degrees, comma 0. All right, so for these weird problems where we have to cut it in thirds, sometimes people find it helpful to write out the red coordinates first. So why don't we actually try that? So our first point was at 0, 0, and I'm talking about the red points. Our next one was at 45, comma 1. Then we went back to 90, comma 0. Then our low level point was 135, negative 1. Then we had 180, comma 0. All right, so imagine all of those points are going to shift 60 degrees to the left. All right, so basically just subtract 60 from all of the x coordinates. This one's going to go to negative 60, 0. This one's going to negative 15, 1. Next one would go to 30, comma 0. 75, negative 1. And we'd have a 120, comma 0. All right, so if you're having trouble shifting the points visually, you could write out the coordinates like that. All right, so I've already graphed some of these. I have this one, the 30, comma 0 we have in green, and the 75, negative 1. All right, so we need the 120, comma 0. That'd be right here. All right, so let me try to connect some of these. So I'd have the wave going like this. And notice the x's, they change by 45 degrees in between points. So if I wanted to just kind of follow the pattern, the x's are going up by 45, and then you have to figure out what level you're on. So we were at 0, then 1, then 0, then negative 1, then 0, and so now we should be back at positive 1. All right, so 165, comma 1 is also on the graph. All right, so the graph looks kind of like that. All right, number 5, that one finally has a vertical shift. So let's go in order. The amplitude is the absolute value of 3, so 3. The period looks like they want radians for this one, so it's going to be 2 pi divided by 2/3, which is the same as 2 pi times 3 over 2, which is 3 pi. There is a phase shift. Negative means to the right, so this is pi to the right. And then there is also a vertical shift. So because of the +4 on the end, we have a vertical shift of 4 up. All right, so because of the vertical shift, we don't just want 3 and -3 on our y-axis. We actually want to add 4 to all of those. So usually we have a top level of 3, a middle level of 0, and a bottom level of -3. If we add 4 to all of those, our top level of our building is now going to be 7, our middle level is going to be 4, and our bottom level is going to be +1. So everything's going to be above the x-axis. So I'll just kind of estimate where it would be. So 1, you could say, is here. We'll put 7 here, and we'll put 4 in the middle of those two. All right, on the x-axis, we want the period number. So we want 3 pi. Cutting that in half, we have 3 pi over 2. And then cutting that in half, we have 3 pi over 4. And then I just take the 3 pi over 4 and multiply it by 3. So this would be 9 pi over 4. All right, so in red, I'm going to graph some points that would be on the graph if it wasn't for the phase shift. So I am going to include the vertical shift, but I'm not going to include the phase shift. So remember that sine likes to start on the middle level. Then it goes upstairs first. Then it goes back to the middle level. Then it goes to the bottom level, and then again back to the middle. All right, so it might be helpful if we write out those coordinates and then apply the phase shift. So the first coordinate we did was 0, 4. Then the second coordinate was 3 pi over 4, 7. And then 3 pi over 2, 4. Then 9 pi over 4 with a y-coordinate of 1. And then 3 pi with a y-coordinate of 4. All right, so looking at our phase shift, and again, we already accounted for the vertical shift. For the phase shift, we have to add pi to all of the x-coordinates. So the first point is going to go to pi, 4. All right, for the fraction, adding pi is like adding 4 pi over 4. So this one's going to 7 pi over 4, 7. This one's going to, I'm going to add 2 pi over 2, which is 5 pi over 2. I'm going to add 4 pi over 4. So this is going to 13 pi over 4. And then I'm just going to add pi to this one. This is going to 4 pi, 4. All right, so graphing those points, it'll be tough to shift pi to the right because our x-axis is counting by pi over 4. So this is another one of those where we have to cut each little section into thirds. All right, so if the first increment was 3 pi over 4, if I cut that in thirds, each of these is pi over 4. So now pi over 4 is like 4 tick marks. So again, you could try to shift the red dots visually, or you could use the coordinate method. Whichever method you find easier is what I recommend. All right, so our first coordinate is going to be at pi, comma 4, which is right here. So the first red dot we had on the left is going over there. All right, the first top level point we had, that is going over here. All right, so I'm going to go from right to left. And then I need another bottom level point, and that would be right here. On the test, I'll try to avoid giving you guys problems where you have to cut the sections into thirds. All right, number 6, we have an amplitude of the absolute value of -4, which is 4. We have a period of 2 pi divided by 2, which is pi. We have a phase shift of pi over 2 to the right. And we have a vertical shift of 1 up. All right, with an amplitude of 4, we usually go up to 4. 0 is our middle level, and -4 is our bottom level. If all of those are going to get increased by 1, our top level is going to be at 5, our middle level is going to be at 1, and our bottom level is going to be at -3. All right, so I'll just kind of estimate 5 is like there, 1 is here, and -3 is around here. All right, because our period is pi, I'm going to put pi right here, cut that into half first, and then cut those into quarters. All right, so in red, I'm going to graph the points without the phase shift, but I will incorporate the vertical shift. All right, so cosine likes to start on the top floor, but it's opposite day because there's a negative in front of the 4. So again, cosine likes to start on the top floor, but on opposite day, they start on the bottom floor. Then they go to the middle level, and then the top level, then back to the middle, and then to the bottom level. Those red points need to shift pi over 2 to the right. So pi over 2 on this graph is 2 of the increments that we have. All right, so I would shift the top point. So I'd shift this top point and have it go pi over 2 to the right. So it'd go over here. And then we could just work around that point. So if we're on the top level, next we have to go to the middle level, and notice there's already a point there. That's okay. All right, and then after the middle level, we go to the bottom level, then back to the middle, and then to the top. So I graphed that and shifted it visually. If you need the coordinates, let me show you how that would work. So the red coordinates that we had were 0, -3. Then that middle one is pi over 4, 1. Then we had pi over 2, 5. Then we had 3 pi over 4, 1. And we had pi -3. All right. And then these points all got shifted pi over 2 to the right. So this one went to pi over 2, comma -3. I'm just adding pi over 2 to the x-coordinate. A quarter pi plus half a pi is 3 pi over 4. All right, add pi over 2 to this x-coordinate. Pi over 2 plus pi over 2 is pi. And then these are kind of off our graph. This one's going to go to 5 pi over 4, comma 1. This is going to go to 3 pi over 2, comma -3. And notice that our green graph has this point, and it also has this one, and it has this one. And then you could just kind of use the patterns to find the other two. The pattern of top middle, bottom middle, and so on. All right, the last two, we have some reciprocal graphs. All right, so for this one, there is no amplitude, only sine and cosine has an amplitude. Amplitude is undefined. Period is 360 divided by 3. Period is 120 degrees. All right, I'll kind of abbreviate. Our phase shift is going to be 45 degrees to the right. And then our vertical shift is 1 up. All right, so with that 1/2, that would normally be our amplitude. That would usually give us levels of 1/2 at the top, 0 at the middle level, and -1/2. We have to add 1 to all of those. So adding 1 to all of those, we would be at 1.5, or 3 over 2. Middle level is 1, and then our bottom level is 1/2. On the x-axis, we want 120 degrees. We cut that in 4. All right, in red, I'm going to do some sine points that account for the vertical shift, but that doesn't account for the phase shift. All right, so cosecant reciprocal is sine. Sine likes to start on the middle level. Then it goes upstairs first. Then it goes back to the middle. Then it goes to the bottom level. Then it goes back to the middle. All right, so cosecant has asymptotes when sine is at the middle level. But now we have to account for the 45-degree phase shift. So we don't have to cut these increments into thirds. we can get away with just cutting them in half on this one. All right, so if I cut all of these in half, now they're all 15 degrees apart, and that allows us to see where 45 degrees is. All right, so I guess in blue, I will shift all of those red dots 45 degrees to the right. All right, so the very first one on the left is going to go here. And then the top level one is going to go over here. The second middle one is going here. And then the only bottom level one we have is going to go just a little bit to the right of the graph. And then following the pattern, I know that there's going to be another bottom level here. So a couple reasons I can tell is, one, I know the period is 120. So if I take the coordinate on the very far right and I subtract 120 from it, it should be at the same level. Right, so those blue dots, those are not part of the cosecant graph, those are part of the sine graph. And remember that cosecant has an asymptote whenever sine is at a middle level. So let's put an asymptote through those middle level blue points. And then we could just draw our upward opening parabolas. And then half of a downward opening one. And another half that opens down over here. All right, number 8 has an amplitude, well, it would have an amplitude of 2 if it was cosine. But secant has an undefined amplitude. The period is 360 divided by 1/2. So 360 times 2 is 720 degrees. There's a phase shift of 90 degrees to the right. And there's a vertical shift of 1 down. All right, so usually this 2 means we have a top level of 2, a middle level of 0, and a bottom level of -2. We want to subtract 1 from all of those. So our top level is going to be at 1, middle level at -1, and our bottom level at -3. Right, our period of 720 goes toward the end of the x-axis. Cut that in half. Cut it in quarters. All right, because we're going to be shifting 90 degrees to the right, I want to cut each of these in half so that I have a idea of how far 90 degrees is. All right, so I'm going to make some cosine points. These are not going to account for the phase shift, but they will account for the vertical shift. So cosine likes to start on the top level. Then it goes to the middle level, and ignore the green divisions. Then it goes to the bottom, and back to the middle, and then to the top. All right, now all those red points need to shift 90 degrees to the right. So 90 degrees is just one tick mark, including the green ones. All right, so the first red point's going to go over here. Second red point's moving there. Third red point goes here. Fourth red point goes here. Then we'll have to go a little off the graph. The other red point goes there. Right, whenever we're at the middle level, that is an asymptote. And then we make our parabolas. We'll make half a parabola here and another half on this side. And that does it for 12.8.